Okay, so last day, wherever we left, from that point I want to take the questions I'm going to discuss first, right? Only questions are left out today. I mark it as question number 1 only, but this is, I think, question number 9 of the book. So I'll first draw the figure of the question, and then I'll write the restatement. Then you'll be able to understand what question is this, right? So this is a very important question of the book. So here what they have given, there is a circle. There is a circle. I'll be giving the name of the center as O. Suppose the center of the circle is O. Then there are two tangents which are parallel tangents. There are two tangents which are parallel tangents drawn in the two sides of the circle. This is one tangent. Okay, so now the other tangent is here. I may be changing the point of contact here. This is the other one. So now let me name the point of context. Suppose this be the point P. I may not maintain the same point of contact as it is in book. So this please see, this is Q. Then one more tangent we have to draw. One more tangent we have to draw, and that tangents will be drawing here. This is another tangent with a point of contact here. This point of contact, suppose I want to name it as R. These are the informations so far given to us. Then, of course, till now I did not maintain the name of the tangents. Let me name the tangents. It will be better. This is T. Then this point is, suppose, T dash. Sorry, T dash. And this is, suppose, U. And this is U dash. So these are the two tangents which are parallel. They are touching the circle at P and Q. A third tangent is there, which is touching the circle at R, and it is intersecting the earlier two tangents at 2 points. Say one is X and the other point is Y. So now what we have to prove is that angle XOY equal to 90 degree. So because of that, we have to join this. This we have to join, and then this we have to join. We have to prove that this angle XOY is equal to 90 degree. So this is the thing. Now we'll be writing the restatement. If in case any further thing we need, we'll be constructing on due course of time. First, we'll be writing the restatement. Here, O is the center of the given circle, and tangents TT dash parallel to U dash are drawn at P and Q respectively to the circle. So we have drawn this. Fine. Also, tangent XY is drawn at point R to the circle. Now to find, I am writing to find angle XOY. To find angle XOY, we have to determine what is the measurement of the angle XOY. This angle measurement we have to find. Okay. So now we'll be needing one more line segment that we are going to draw. P and Q you have to join. P and Q, the point of contact. This you have to join. Right? So we have joined this. Or in fact, if you do not say PQ is joined, you can say OP and OQ are joined. Ultimately, they will be forming a diameter. Okay. Now, how we'll proceed? One more line is to be joined. That was left out. This is OR is to be joined. So this, if you want to mention, you can mention in the construction step. I am not going to mention this. So this, if you want, you can mention this. Fine. Now, how will proceed? You see, I can prove it. I'll show the proof. This angle is equal to this angle. This is 1, this is 2. Because I have a theorem last day we derived that the line segment joining the center to the point from where tangents are drawn bisects the angle between the tangents. With that logic, similar logic I can apply this side also. I can say angle 3 equal to angle 4. Right, that's the idea we have now here. We are going to use. Right, so now we'll proceed for that proof. So construction, you will write yourself. What we'll write now, we know that we'll use that theorem. We know that the line segment joining the center to the exterior point from where tangents are drawn to the circle bisects the angle between the tangents, right? Therefore, we can write angle 1 equal to 2 and we can write angle 3 equal to 4. These are the two implications we can get. Readily we can get these implications. There is no problem at all. Fine. After that also we can write. So I'll write here only. Also we know that the sum of the co-interior angles in the same side of the transversal of a parallel line, of a pair of parallel lines are supplementary. Supplementary means sum will be 180 degree. So here you see where I am finding this. These two are parallel lines. This is the transversal. So this angle plus this angle are co-interior angle in the same side of the transversal. So you have to get their sum equals how much? 180 degree. So I can write therefore angle PXY plus angle QYX equal to 180 degree. Now PXY I can write as 2 times of angle 2 and QYX I can write as 2 times of angle 3. Now from here this calculation tells us that angle 2 plus 3 is equal to 180 degree. Angle 2 plus 3 is equal, it is 90 degree because 2 will be taken common and then this is 90 degree. This is 90 degree. This is equation number 1. This is equation number 1. Right? So now I'll be changing the board for completing the rest. Now by angle some property of triangle in triangle XOY, we get angle 2 plus 3 plus angle XOY is equal to 180 degree. This 2 makes it 90 degree. So this XOY will be ultimately 90 degree. So this is what our main measurement is. So I did not say that you prove it. I have just told that you find it. So this is the question. It's a very important question. It's a board question. It came in the board. Now I'll be taking the next question. Very important question again. Question number 2. Okay. This also came in the board. So that the opposite sides of a quadrilateral circumscribing a circle subtends. That means subtends means produces subtends supplementary angles at the center of the circle. Once we'll draw the figure, everything will be clear. So now I'm going to draw the figure. So we'll draw the figure first. We'll draw the circle first, then it will be easy for us to draw the quadrilateral. So circumscribing a circle, matlab quadrilateral is outside, it is not inside. The quadrilateral is outside the circle. So let me adjust the figure a little. Okay. So we have a quadrilateral. Let me give the name as this vertex is suppose A, this vertex is B, this vertex is C, and here it is the D. So ABCD is a quadrilateral which is circumscribing a circle whose center is at O. So let me name the center as O. And then circumscribing meaning is what? That the side of the quadrilateral must touch all the circles at 4 different points. So now let me name the points also because they will be of use. So this is suppose P, point of contact. This point of contact is Q. This point of contact is R. And this point of contact is S. So these are the 4 points of contact of the sides of the quadrilateral with the circle. Now what exactly we have to prove? You see, opposite side of the quadrilateral. So AB and CD are opposite. So they are going to form this angle here and this angle here. That means I have to show angle BOA plus COD is 180 degree and BOC plus AOD is 180 degree. So very clearly you have understood that we have to now join some other sides as well. Without joining that, the proof will be not possible. So we are going to join these things because we have to create the angle. So this we have joined, that angle AOB is formed. Then now we are going to form the angle COD. This angle COD is formed. But merely joining this is not enough. But what parts will be to be joined? We'll do it afterwards. First we'll write the restatement. First, we'll write the restatement. Please draw the figure and we'll write the restatement. Let ABCD be a quadrilateral which circumscribes the circle with center at O. Right? Let PQ RS be the points of context of the sides AB, CD, AB, BC. Let me correct this. AB, BC, CD, and DA, respectively. Okay. Now, to show that angle AOB plus angle COD is equal to 180 degree and angle BOC plus angle AOD is equal to 180 degree. So this is our target. Now, as we have already got angle AOB mentioned in the question, so you need not write in the construction about joining AO and AB or OB, etc. Now, whatever we are going to construct, that you can mention in the construction. So here what we have to do is that this point of context we have to join. This point of context we have to join. All this. You can join this by dotted line. I do not have option here. These four things we have joined, and this is to be mentioned in the construction step. Right? And moment we join, you can easily identify that these angles will be 90 degree by the first theorem. Radius to the point of contact is perpendicular to the tangent. That we are going to use here. Right? So please note it down. We'll now mark some angles here. See, we are going to mark this angle. Just see it. Angle 1 will be equal to angle 2. Why? I'm going to use that theorem directly. That this is the line segment joining the center to the point of contact. So it divides the radius to the point of contact. Angle between the radius equally. So 1 will be equal to 2. Similarly, if I name this angle 3 will be equal to 4, then this angle 5 will be equal to angle 6. Similar logic I can apply. This angle 7 will be equal to angle 8. So this is the logic we have used, right? So after this, we are going to change the board now. I'm going to write the construction. So what is the construction we have done? Construction is that OP, OQ, OR, OS are joined. We have joined this. Now proof. First we'll write a theorem what we know. Right? We know that the line segment joining the center of the circle, right, to the exterior point from where tangents are drawn to the circle bisects the angle between the radii through the point of contact, through the point of context, right? If you feel that this statement is bigger, you show the congruency of the triangle and directly you write the results. So if this is the case, we can get conclusion. Already we have done. Angle 1 will be equal to 2, angle 3 will be equal to 4, angle 5 will be equal to 6, angle 7 will be equal to angle 8. So all these will be marked as equation 1, right? All this will be marked as equation 1. So I can write now angle 1 plus angle 2 plus angle 3 plus angle 4, a big sequence we are writing. This whole angle is going to give me 360 degree. So you can give a reason since angle about a point is of measurement 360 degree. It is a complete angle we are considering. Now, as per the previous idea, we are going to replace some of the angles. Which are the angles we are going to replace? Just let us try to understand. We are going to replace 1, we are going to replace 4, we are going to replace 5, we are going to replace 8 by its equal angles. So now angle 1 can be replaced by 2. So we have replaced 1 equal to 2. From here we got this. And angle 2 I want to keep. 3 I want to keep. I want to replace 4. Right? 4 can be replaced by 3. Very nice. I want to replace 5. 5 can be replaced by 6. Angle 6 will be kept. Angle 7 will be kept. Angle 8 will be replaced by 7. So we have replaced successfully. And what equation we have used? By 1. Very nice. What is the benefit? Every angle is coming 2 times. So that 2 I have taken common. And then we can write the angle like this. It is 360. Right. Now, in the same step, we are going to do 2 calculations. You see. First of all, this angle, if you look at the figure, I'll go back to the figure. 2 plus 3 will give you AOB and 6 plus 7 will give you COD. So, we can write this as AOB. I'm writing in a rough right at this moment. This I can write as COD. And these 2 I'm going to use to divide 360. Right? So, in the next step, we are going to get the result from here. What result I'll get? These 2 will be divided by 2. I'll be dividing both the sides. So, I'll be getting AOB here and I'll be getting COD here, and this is equal to 180 degree. And now you see, it is one of the part. This is one of the part we have done. This is one of the part we have done. Please write this. So after this, what we are going to do, you see. Now also you can write again. If you look at the figure, I can say angle AOB plus BOC plus COD plus AOD. These are going to make it 360 degree. My task of AOB and COD is over. So what I do, I want to keep BOC and AOD in the left side. And I want to subtract these 2 angles whose task is over. And now easily you can identify that this value is 180 degree. So this is also 180 degree. Therefore, you have got this equals to 180 degree, and that's the proof. Henceforth, this is an important question. I think this year only it came. I'm not sure about that, but it is important. Please go through it. Now I'll be starting with question number 3. Actually, this is question number 4 of the book. I'll write the question so that you can easily remember it. Prove that, PT means prove that the tangents at the ends of a diameter of a circle are parallel. This is what you have to prove. So it's a very easy problem. So let us draw the circle and then we will be doing the proof easily. This is the circle we have drawn, right? We can give the name of the center. This is the center. We'll be giving the name of the center of the circle as a O, and we have to draw a diameter. We'll draw a diameter. This is the diameter. Now at the ends of the diameter we have to draw two tangents, and we have to show that these two tangents are parallel to each other. So this is one of the tangent, and then another tangent is here, another tangent is here. So now I have to prove that these two tangents are parallel. So let me give the name to the tangents with its point of contact. Say this is say T, then this point is T dash, and point of contact, let me give it as A, and then the other suppose tangent is S, and then this is S dash, and point of contact B, suppose B. So we have named it. Now my task is to prove that T dash and S dash are parallel. During the construction, I have to draw them parallel because there is no way out. Otherwise, proof will not be good looking. Now we'll be writing restatement. You write yourself. I'll be just telling you. Restatement is what? Let O be the center of the circle and AB be any diameter, and T dash and S dash be two different tangents drawn at A and B, to prove that T dash is parallel to S dash. So you can write this. It is sure. Construction is not needed. We'll be just writing the proof. You see now. We know that the radius through the, ये theorem है, through the point of contact, right, of a tangent to a circle is perpendicular to the tangent. Therefore, now if you look at the figure, I can say that this angle is 90 degree, and at the same time I can say that this is 90 degree, right? So I can write, therefore angle T dash A B is equal to 90 degree, equal to angle S B A, right? That is, angle T dash AB is equal to SBA. Now look at those two angles. They are alternate angles, right? And they are equal. Alternate angles are equal means the line which were already there, intersected by the transversal, must be parallel. So we'll write which are alternate angle, which are alternate interior angles, right? Produced. When it is produced? When TT dash and SS dash are intersected by AB. Therefore, we must say that this line is parallel to this line. That is, tangents are parallel. Tangents at A, B are parallel. Hence, we prove it. Please note down this. Now we are going to take the next important problem. That is perhaps the last question of the exercise, your circle exercise in the book. This is a very important question, very important question, and it came in the exam also. So here I will not write the question, I will directly draw the figure and then I'll explain you what exactly is to be done. Right, so you'll understand it. It is not a difficult one, but the question is longer. So there is a circle, and this circle is circumscribed by a triangle distance. That means a triangle is outside the circle in such a way that it is touching the circle, its sides are touching the circle. So likewise, we have drawn the triangle. Fine. So this is a triangle which is circumscribing the circle, right? I'm going to rename the triangle. There may be some difference in the name, so don't worry about that. Question remains the same. Say this is the triangle. These are the vertices ABC, and the center of the triangle I would like to name it as O. O be the center of the triangle. Sorry, center of the circle. Inscribed circle. Now, what they have given you, try to see. In the question, this is the only question given, that a circle is inscribed in a triangle, or you can say a triangle is circumscribing a circle. Radius of the circle is given, that is 4 centimeter, and side BC has been divided into 2 parts. They have given you the measurement of that 2 parts. Now I am going to write the measurement of the 2 parts. Up to here there is a measurement, and up to here there is another measurement from here to here. Right? These measurements may not be exactly same as the book. My figure, whatever it is indicating, this I'll consider as 6 centimeter, this as 4 centimeter. That means total length of BC is 10 centimeter, right? And then these radius, this radius is of 4 centimeter. But my only these things will not work, so I have to join these all points. So I am joining this. This is the construction. Similarly, we have to join this point with center. You can join these by dotted lines. This point here and this points here. All these we have joined, and these are all constructions, because nothing is mentioned in the textbook about these lines. This all we have done. And now here I would like to just name the points of context also, because I will be in need of all these. So please go on marking these points. This is R, right? And this measurement is 4 centimeter. This measurement is 4 centimeter. Great. So this is what we have got. And now I have to find what are the other 2 sides. So please complete the figure. So now we'll be finding the value of what is the measurement of AB and AC. Before that, some prerequisite idea we can use. What will you use? You see, from B, you can say that these are the 2 tangents, so their length will be equal. As this is 6 centimeter, this will be also 6 centimeter. Similarly, as this is 4, this will be also 4. So what I don't know is these 2 measurement. So this will consider as X. So automatically this will be X. So this is what we have to now infuse here in the figure. So here this measurement is 6 centimeter. This measurement is 4 centimeter. This measurement we are going to consider as x centimeter. So in way, this will be also 6 centimeter. And all these radii will become 4 centimeter each. It is given already. So this is what we have started with. Now you see how we'll proceed. First of all, we talk about these equalities because this is a part of the formality. This statement you write yourself. I'm just doing the solution part. We know that the length of the tangents drawn to a circle from an external points, not points, external point are equal. So that leads us to say that measurement of BP is equal to BQ is equal to 6 centimeter. Number one, measurement of CR is equal to CQ is equal to 4 centimeter. And then measurement of AP is equal to AR is equal to X centimeter. And here we write say because this measurement we have introduced from our side. Okay, so this is done. Now in the next part what we'll say. Also, see, we have to find a relation between x so that we can find this. That's the idea. X का कोई relation निकालना चाहिए हमको. Then we'll be able to find the value of x. So area of ABC, you look at the figure, then automatically you will understand, can be written as area of AOB plus area of triangle BOC plus area of triangle AOC. Now just what I have written, I am telling you, पूरे ट्राइंगल का एरिया, इसका एरिया, इस ट्राइंगल का एरिया और इस ट्राइंगल का एरिया का सम होगा. There is no complications at all. And at the same time, this will be working as the height for this triangle and this is the base. For this triangle, this is the base, this is the height because these are perpendicular. Why are these perpendicular? The first theorem says, right? So if you want, you can mention this, but this is a long problem. If you do not mention, then also it will be okay. So I'll directly write the area. What is the area formula of a triangle? It is half into base. Base means here it is BC, and then altitude. Altitude means OQ here. Please at the same time look at the figure also. And then, sorry, I made a mistake. I'm sorry. I only made a mistake. I wrote the second triangle's area here. The base is AB and then height is OP. Here for this base is BC and height is OQ, and this is AC and height is OR. Very nice. Now you can see each of this OP, OQ and OR. Therefore, I can take common. Half is also there. I can take common. So half R into measurement 4. I could have written directly this as 2 only. Now you write the measurements of AB. What is AB from the figure? It is, look at the figure, it is 6 plus x. BC is 6 plus 4 and AC is 4 plus x. Very nice. So this is going to give you 2, then x plus x, that is twice x, then this is 6, this is 6, 12, 12 plus 8 is giving you 20. So 2 can be taken common. So I am getting this as this much. So this is the area. What I got is the area of the triangle. So this is the area of the triangle we have found. We'll proceed for the next part. What is the cleaning now? You see, we have got only one part. You see, left side, I don't know anything. Only it is containing x. So I have to get one more expression for area so that it will also contain x. So that means I am going to find the area of the triangle with some other way. So other way means I am going to use the Heron's formula here, right? So Heron's formula you should remember. So for Heron's formula we need the semi-perimeter. So now we'll be writing. Now S is what? Semi-perimeter, right? Semi-perimeter of triangle ABC. Now semi-perimeter means sum of all the sides divided by 2. Sum of length of all the sides divided by 2. So you can directly write this. So we can now directly write it. You see, it is 6 plus 6, 12, 4 plus 4, 8. So 20, 20 plus twice x. So that means I can write this as twice x plus 20 divided by 2, giving me this as x plus 10. So we have come up to the semi-perimeter. Now we are going to apply the Heron's formula to find the area directly, right? And then we'll be comparing. So now by Heron's formula, we got it in class 9. Area of triangle ABC, area of triangle ABC is equal to, right? So can you remember the formula? It was a big formula as S minus A, S minus B, S minus C. Good. So we are going to give this input. Okay, S means x plus 10. Now see, these things we are going to do directly, very directly. A means the side opposite to angle A. So that means I am talking about this 10 BC. So directly you write x plus 10 minus 10 will give you x. Okay. Next will be B. B is the side opposite to angle B, that is x plus 4. So I have to minus x plus 4 from x plus 10. So I'll be getting this as 6. And the last one also you can work on, it will be 4. So this is the area. Little workout you can do if you want. What I can do is, let me not multiply everything. We'll keep it as 24x and x plus 10. This is the area we got from the, now this is the area we got from the Heron's formula of the same triangle, and this is the area we found with this particular three triangles. So as we are finding the area of the same triangle, it means they are both equal. So that's the thing we are going to do in the calculation. So I can write, therefore, right, the first area was, I forgot, just I'll have to see, it is 4 times x plus 10, 4 times x plus 10, and this is equal to root over 24x, it is x plus 10. Now from here we have to find the value of x. So we got a very comfortable equation. So we'll square it. We'll square both the sides. So if I square it, do not break the square immediately. We'll get this, and this will get free from root over. So you'll be arriving here. Now what we'll do, we'll shift this to the left side, right? So this is 16 x plus 10 square, then 24x, it is, okay, 10 plus x, I can write this as x plus 10 also. Now whatever is possible you take common. 8 I can take common, and x plus 10 I can take common. So if I take this, I'll be left out with 2x plus 10, and then here I'll be getting 3x. So now you go for a small simplification, x plus 10, and this is 2x minus 3x will give you minus x, and then 2 into 10 will give you 20. No, some calculation error is occurring. Okay, that is mistake is here. that it is 6 and 8, right? So it will be 8 and it will be 6. So this will be 8, this will be 6. So here, where will be the correction needed? 6 plus x means it will be 8 plus x, it will be 6 plus 8 I'll make, and then this is 6 plus x. So your answer is 16 plus 12, 28 plus 2x. 28 plus 2x. So it will be 14 here. Similarly, it will be 28, so it will be 14 here. Correction is yes, no problem. And then here, this minus 14 it will be 14 only. This is 14, this will be x, and 14 minus 8. These things are okay. These things are okay. This will be only 14. That is, these things are not okay. Sorry, 8. And then if I multiply, this will be 8. This will be 8. Okay, so it will be 48. Not okay. Thank you for correction. Actually, the problem I did not see, that is the mistake I did here. 8 was a 48. Okay, thank you so much. So now it will be corrected. Now it will be corrected. So it is 14. This will be 14 and this is 48. This will be 48. Okay, this let me remove only because this will create any problem here. This will create a problem here. Okay, so what we'll get here is 16 x plus 14 whole square, 48x, x plus 14. So now, yeah, this will cut directly 8 by 3. So now if I try to transfer this, x plus 14 can be taken common. Here it will be x plus 14 and in the left side it will be 3x. That will be equal to 0. So I'll be getting x equal to minus 14 or twice x equal to 14. So this is rejected. Measurement cannot be negative. So this is going to give me 7. So x is 7. Therefore, AB it was equal to x plus 8. That give me 7 plus 8. That is 15 centimeter. And AC it was equal to x plus 6. That give me 7 plus 6. That is equal to 13 centimeters. So you have decided the size. AB equal to 15, BC equal to 14, and AC equal to 13. So little time has been wasted because of this measurement. Actually, we were not wrong. My triangle, when I considered the measurement, it was wrong. Anyway, no problem. So we have finished with the chapters, but still there are 5 or 6 important problems that I'm going to take in the next period. This is very sure we have to do it.